Hi there, I'm Marc. One more thing about infeasible problems. At first glance, infeasibility is a nightmare. A problem is unsolvable. And now? But solving these problems anyway is exactly what makes our jobs as optimization experts so exciting. And that's what we do at Obtaino. In mathematical optimization, infeasibility means having a problem to which there is no solution that satisfies all constraints. Of course, this is not good, because our customers naturally want an optimal solution. And no solution is obviously far from optimal. Let's say we have gathered all the necessary data, created the mathematical model, and now start the optimization. Bam! Infeasible. What happened and what can we do now? There are mainly three reasons why infeasibility can occur: wrong implementation, inconsistent data, unfulfillable constraints. So first we check if the optimization model is correct. If everything works as intended, we then take a closer look at the data. A common mistake, for example, is wrong units, like a 5 kilogram screw or so. Sounds stupid, but actually happens quite a lot. If the model and the data are correct, this means that we have unfulfillable constraints. Now the detective in us is coming out. Where is the fault? Let us have a look at an example for that. Let's say we are looking at a transportation problem where we have demands who need to be shipped between different locations. For this kind of problems, you usually have a limited number of assets, let's say trucks, for transporting the goods. And on the other hand, we have service levels for the demands. In our original model, we might have required that all demands are shipped within the defined service levels. But what if there simply is no solution where all demands can be shipped on time with the available number of assets? What we can do now is making hard constraints soft. This means that we allow the model to violate some constraints and penalize the violations. In our example, that could mean that we allow the model to either use additional assets or delay the demands. New assets would then be penalized with acquisition costs, whereas delay costs would be defined based on some kind of service level agreements. This way, not only does our model become feasible again, but it now also takes a decision between buying new assets or violating service level agreements into account, and thus maximizing overall profit. Awesome, isn't it? Infeasibility sounds much worse than it is. For us, it's totally exciting because it takes us to the core problems in the planning process and often helps to identify the most crucial points for improvement. So next time when your model is infeasible, no need to panic. Happy investigating and see you next time.